Okay, so these co-function identities make sense if I draw a picture. Okay, so I'm going to draw a picture here underneath of a triangle. And I've got a 90-degree angle, and I'm going to label this A, B, and C. Okay, now if I A was 20 degrees, what would B have to be? 70 degrees. So our triangle adds up to 180 degrees, right? So angle A and angle B, how do those relate? What do we call those? They're complementary, right? They add up to 90 degrees. So if I wrote a trig function for sine of A, so sine of 20 degrees, or this is technically A, right? I have to come up with some side links here. Let's say this is 4 and let's say this is 7, which means I think this is like the square root of 33, maybe. Okay. What would my trig function or my ratio look like for sine of 20? What over what? 4 over 7. So from yeah, opposite hypotenuse. Yep. If I did cosine, however, of B or cosine of 70, what am I also going to get? 4 over 7. Okay, we kind of figured this out like a few classes ago when we were doing that unit circle discovery thing. We saw that the sine of like angle A and the cosine of angle B are always going to give us the same values. Okay, so we call those co-function identities. So if you look at this formula over here for sine, it says that sine of A, or sine of 20 in our case, is equal to cosine of 90 minus 20, which is 70. So cosine of 70 is equal to sine of 20. Do you guys agree from that picture? Yeah, so that's all that identity is saying. And it also works the reverse way as well. So like if I had cosine of A, that would be sine of 90 minus A. Okay. For cosecant, that's also technically secant of A is equal to cosecant of 90 minus A. And then tangent is also cotangent of A is equal to tangent of 90 minus A. So if we use those cofunction identities, we can answer these following 3 questions. One other thing I want to point out is if it was in radians instead, what is 90 degrees in terms of radians? Pi over 2, right? So just a note there, remember 90 degrees is equal to pi over 2. So if we're given something in radians, you should always answer in radians. If you're given something in degrees, then you should answer in degrees. Okay, this next quiz that we're going to have, I'm not going to be able to tell you like, hey, be in degrees for the entire quiz, you'll be fine. You're going to need to know when do I need to be in what mode for what question, okay? So you got to be careful, and you got to show your work. So if I look at example A, we're going to use our calculator quite a bit today, so make sure you got your calculator out. We are finding the cofunction of this. If I'm evaluating the cofunction of cosine, okay, the cofunction of cosine is going to be sine, so that would be sine of 90 minus this 52 degrees 16 minutes. And since it is in degrees, I'm just going to subtract 90 minus 52 degrees 16 minutes. You're just plugging this piece into the calculator, not sine of that entire thing. That would be if it said to evaluate it. But this would simplify to give me, double check you get this on your calculator, 37 degrees and 44 minutes. Now, on your calculator, you also might get like 37.733, I think, or something. Yes? So if you get that, you can change it into a degree in minutes by going to the DMS option underneath second apps. Okay, that'll change it into degrees in minutes. Now, unless it specifically said to give your answer like that, technically leaving it in leaving it in decimals is fine with me, okay? But if it specifically says to leave it in a certain form, you need to leave it in that certain form. Okay, this next one here, we've got tangent of pi over 6. So the cofunction of tangent is cotangent. So I would do cotangent of, now this is in terms of radians now because I've got a pi there. So I would change this to pi over 2, and then I would subtract the pi over 6. But can I simplify that fraction? Yeah, this would be the same thing as cotangent of 3 pi over 6 minus pi over 6, which is also the same thing as cotangent of 2 pi over 6, which we could simplify one more time to be what? Pi over 3. Okay, so we're not evaluating it, but that is our final answer for our cofunction. Last one here, secant of 1. Is this a degree? Is this a radian? It is a radian. There is no degree symbol there, so it is a radian. Just because it doesn't have a pi in it doesn't mean it's a radian, okay? There is no degree, so we will be using pi over 2 to evaluate this. So the cofunction for secant is going to be cosecant. So I would take the cosecant of not 90 minus 1, but pi over 2 minus 1, because it is in radians.
Is that like negative pi over 2?
Pi over 2 minus 1?
Yeah.
Nope, we can just leave it like that. Pi over 2 minus 1. You could also write it if you wanted to as like one fraction, as like pi minus 2 over 2 technically, is what that is. But it will still be positive because like pi is like 3.14 minus 2 would be like 1.14 and then divide by 2. So it's about 1/2. It's like a little bit bigger than that. Okay? Alrighty, moving on to the next page. Okay, we've kind of already talked a little bit about these reference angles, but haven't necessarily like gone exactly into like what does the reference angle tell us. So we've got this picture over here on the right. We've got these 4 quadrants. Okay, the reference angle is what we've been doing, but just haven't been saying that necessarily. The reference angle is the acute angle made by the end or the terminal angle of your side or side of your angle and the x-axis. So it's the thing that's closest to the x-axis and 0, 0. Okay, that's where we always draw our triangles at on our coordinate plane. So if I gave you, like for example, if I look at letter A, 218 degrees, I always suggest drawing yourself a picture of where is 218 degrees. Well, 218 degrees is going to be in what quadrant? The 3rd quadrant. Okay, so 218 is somewhere down here. Okay, that means this whole thing is 218 degrees. But my reference angle, what I actually care about, is this piece closest to the x-axis. What would that angle be? How could we use our critical thinking? Yes, exactly. Take 218 and minus 180, right? That's going to give me just that angle that's down there below, which would be 38 degrees. So our reference angle is 38 degrees, which is going to help us when we're drawing our like little triangles to solve for our trig functions.
Can we turn it into a co-terminal angle before we do it? Like the lowest.
Okay, so what as he was saying, yes, we are going to take letter B, this 1,387, and we're going to make that smaller by 360 degrees until I find out what that coterminal angle is going to be. So if I draw myself a little sketch here,
My bad.
you're good. I would just subtract 360 until I get a number that's not going to allow me to subtract 360 degrees again. And when I do that, I think I have to do that 3 times. And then what does that give me for my angle there? 307. So if I was drawing the angle 307 degrees, That's going to be in which quadrant? Quadrant 4. So somewhere down here would be 307 degrees. Which means that this angle right here would be 360 minus 307, right? So I did 180 over here because it was just past the 180 degrees, right? But if I want to figure out like what's going to make this a full circle, right? That's a full 360 degrees. I'm going to just subtract. Well, I can't just subtract what that is. So I have to subtract the rest of it that I know. Yeah. So this degree right here is 53 degrees. And technically over here is like your formulas. But again, we don't need to memorize things. We just need to like figure out how and why we get them. So like if you look quadrant 1, if it's in quadrant 1, your reference angle is literally just quadrant, like whatever your angle is, okay? If it's in quadrant 2, we take 180 and subtract whatever our angle was to find our reference angle. If it's in quadrant 3, we can take our angle and then subtract 180 because it's just past that. And then if it's in quadrant 4, we can take 360 and minus our angle to find our reference angle. If you notice here, our reference angle is usually denoted with like a little tilde sign there. So you'll see on the answer key of things like reference angle would have a little apostrophe next to it for your final answer. But you don't have to write that. If it just says what's the reference angle, tell me 53. And then the last one, I've got 5 pi over 6. 5 pi over 6. Where is that going to be? What quadrant? What is it?
150 degrees.
Yeah, that was fast. 150 degrees. It is going to be in the second quadrant, yes. Right over here. Okay, reason I know that is because it's less than pi. 5 pi over 6 is less than pi by how many pi over 6? 1 pi over 6, right? So this whole thing is 5 pi over 6. Which means that this piece, if I wanted to find that reference angle there, we can think of, well, in terms of radians, this is pi, so pi minus 5 pi over 6. Or think to yourself, what plus 5 pi over 6 gives me pi? And that would tell me pi over 6 for that.
What?
Okay, so now we're going to take that reference angle and we're actually going to use it to find all 6 trig functions of an angle without using a calculator, okay? So if I ask you to find all trig functions for the angle 210, first thing I need to do is think, where is angle 210 going to be? Third quadrant? Do we all agree?
Yeah.
Okay, so this whole thing is 210 degrees. But all I care about is what this reference angle is. That reference angle to the x-axis I would find by taking 210 and doing what? Subtracting 180. When I subtract, I get 30 degrees. Okay. Okay, so now what we're going to do is we are going to draw a triangle with this is my hypotenuse, and then my short side, or it might be my long side, depending on my angle. We are going to draw my straight line down to the x-axis there, or up to the x-axis to create that 90-degree angle. So I'm going to draw it exactly as I see it. So it should look like this. Nope.
How do you make triangles like that?
This is on, wait, this is still wrong.
Just flip it to the right.
This is on Explain Everything, but you can also do them in Notability. Why is this? Oh, here we go. That's what I need. Okay. I was really struggling there. Okay, do you guys see how that triangle right there would fit into where that hypotenuse is, that angle terminal side? Okay. So now we're not given anything else other than the fact that this angle right here, this reference angle, is equal to 30 degrees. And we know that this is 90. Okay, which means that this angle down here is going to be what? 60. Okay, so it's a 30, 60, 90 triangle, which means we're going to be able to use that 30, 60, 90 triangle to figure out those side lengths. However, we're not given any side lengths. So, what's the easiest side length that we could give the hypotenuse? 1. So we're just going to say that this is 1. We could really say it's any number, and we'll still get the same answer. But if you say it's 1, it'll be easier, because then we can use our unit circle to help us. Okay, if this is 1, that means my short side across from 30 degrees would be 1/2. And then my long side across from 60 would be the square root of 3 divided by 2. Now, we gotta double check. If it is in the third quadrant, what do I need to add in front of this square root of 3 over 2 and 1/2? A negative. Okay, that's why I always suggest to draw a picture so you don't miss that. And now from here I can go ahead and write my trig functions. Okay, so sine of theta, actually we know what sine of theta is. We know sine is going to be of 30 degrees. Sine of 30 degrees is equal to negative 1/2. Which means that the cosecant is equal to negative 2. Okay, cosine of 30 would be adjacent, so that's negative square root of 3 over 2. And secant is going to equal the opposite, so negative 2 over the square root of 3. And lastly, tangent. Tangent is my y value over my x value, or my sine over my cosine. So that's negative 1/2 divided by negative square root of 3 over 2. It's a giant fraction and a fraction. Can I simplify that? Yeah. If I want to rewrite it, negative 1/2. When I divide, I flip my fractions. So those 2's are going to go away. And we're going to be left with negative 1 over the square root of 3.
Wouldn't it be positive y?
Yes, it would. Good catch. And then that means that my reciprocal function cotangent of 30 is going to be the square root of 3. All right, these next two, we're going to find the exact value without using a calculator, okay? So I need to draw a picture of where is cosine of negative 240 degrees going to be. Negative 240. That means I'm starting at this x-axis over here, and negative means I'm going clockwise 240 degrees. So if I go this way, 240 degrees, where am I going to end up? Second quadrant there, right? So I've got this side length there. That is 240 degrees, negative 240 degrees, right? So how could I figure out this reference angle right there? Plus 180 would give me a negative. So I don't want negative. But if I like the idea. What if I did 240 minus 180? That's going to give me 60. Or if you did negative 240 plus 180, that gives me negative 60, right? But we got to use our brains. This angle right here is not going to be negative. I just want what is that reference angle to the x-axis. This whole thing is just going to be 60, okay? So this angle is just 60 degrees. So now I'm going to draw myself a little triangle, just like how it would be if it was on this coordinate plane, just off to the side. So my triangle would look something like this, where this is 60. We know this is 90, which means that this is going to be 30 degrees. And again, we're not given any side lengths. So let's assume that my hypotenuse is 1. If my hypotenuse is 1, it'll be easy for us to remember what our other side lengths are from our 30, 60, 90. So our short side is going to be 1/2, and our long side is square root of 3 over 2. But which one's going to be negative?
The 1/2.
The 1/2, yep. Negative 1/2. So if we're looking at cosine of that angle, cosine of this angle right here is going to be your adjacent over your hypotenuse. So this is going to equal negative 1/2. Oh wait, where would B go? Actually, I'm gonna let you guys try this one out on your own. Okay, go ahead and try drawing where 675 is, and draw your triangle just like it would be on your coordinate plane, and then try and find your tangent. All right, now the rest of this will be using our calculator. Okay, the best kind of math, but also the scariest kind of math is if you can't use your calculator. These are 3 points that you're gonna miss. Okay, so on your calculator, again, there's degree mode, radian mode. So for these 4 functions, we have degrees. Well, actually, this is degrees in minutes, so we need to be able to plug that in. Degrees. What is this last one? Radians. Okay, so we got to make sure for the last one we change it into radians. Okay. For this first one, you can literally just type it in. Cosine of 49 degrees in 12 minutes. When you type that in the calculator and round it to about 3 decimal places, you should get 0.653 for your answer. And again, make sure you are in degrees. So double check you get that answer. Now, is there a CSC button? Is there a cosecant button on the calculator? No. There is not. Yes, there is not.
Inverse.
There is not. Okay? So we are not going to use the inverse button, but the reciprocal function of cosecant is sine, right? So this is, on our calculator, we're going to type in 1 divided by sine of 197.977, because 1 over sine is cosecant. Those are reciprocals of each other. So if you type this into the calculator with your degrees mode, you should get negative 3.240. Double check you get that answer. Cotangent. What's cotangent the reciprocal of? 1 over tangent. So you type 1 over tangent of our angle, 51.4283. And double check you approximately get 0.797. And then our last one, we need to change this into radians, okay? That is in radians. So change your mode, and when you type it in the calculator, you should get approximately negative 0.988. There is also another slightly weird way to type it in the calculator that will give you the correct answer. So if you want to know what that is, underneath the second apps button, option 3, there's like a tiny little R button, which technically like overrides your calculator, which is in degrees. So if you were in degree mode, so I want you guys to try this, go back in degree mode and then type sine of 30 like this and put that little R there, and it changes your answer into radians. Kind of cool. Don't super know the purpose of it, but that is there, and it should give you the same answer. Okay, so it says to approximate the value of each angle in degrees and in radians that satisfies our given ratio for the given trig function. So for letter A, we're given that sine of theta is equal to this really long decimal. If I want to know what theta equals, how do I undo sine? Well, not divide, but take the inverse of both sides, right? So technically, to find theta, you're going to plug in sine inverse of, and yes, you have to type the whole thing. And if you are in degrees, I want you to try both of them. Your angle in degrees should be approximately 75.4, but your angle in radians should be approximately 1.316. Okay, so try both of them. Make sure you can get both of those answers on your calculator. And then there's one other thing I'm going to talk about with this. So on your homework, one of the last questions that it's going to be on your homework, it's going to ask you to find all of the values on the interval from 0 to 360 degrees that make this trig function true. Okay, so what I mean by that is we have one of them. We have 75.4 degrees, so that's approximately, I don't know, like there. That's 75.4 degrees. And if I take the sine of that angle, this angle here, and I make my triangle, I'm going to get this as my answer. Okay? Now, it's also asking, well, okay, well, where else am I also going to get the same sine value or the same y value? My y value is going to be positive here, right? Where is my y value also going to be positive? Quadrant 2, right? So I can draw the same angle, but over in quadrant 2, and it's going to give me the same answer. But how do I find out what that angle is?
Plus 60, because it's 30, 60.
It's not a 30, 60, 90 though, because this is 75. So if this is 75, how could I figure out what this angle is to that blue line there? 180 minus. Yeah, that's exactly right. So take 180 and minus 75.4, and that's going to give me 104.6 degrees. So technically this angle right there and this angle, okay, will give me the same sine value because they're going to have that same y value, right? Just like on your unit circle, you've got 2 points that are going to have the same y value. And then technically, could I also like add 360 degrees to get another angle that's coterminal that would also be the same? And I could keep doing that. So there's like a ton of different angles, right? But when I do this on the calculator, it's only going to give us one angle, okay? All right, last one. Tangent of theta is equal to 0.25. So if I want to find out what theta is equal to, I'm going to, on my calculator, type the tangent inverse of 0.25. Now 0.25, you can find the answer in two ways, for your degree mode and your radian mode. And you should get 14.036 degrees or 0.245 radians. Okay, and I was talking to them in the back. We could also just take this number, 14.036, and times it by pi over 180 to give us our radian. Either way is fine. Okay, just kind of another way, another tool that you could use to answer and solve that. All right, and lastly for this one, for tangent of this thing is going to give me tangent of 14 degrees. We'll say this is 14 degrees. That's going to give me 0.25, tangent of that angle right there. Okay, so that means that tangent is positive, right? Tangent is positive in this first quadrant, and what other quadrant is tangent positive in? The third quadrant, right? Because all students take calculus, right? So if I wanted to draw this same reference angle of 14 degrees in quadrant 3, I can just continue my line right here, where this is 14 degrees. I don't like how I labeled that. Let's do 14 degrees here, okay? But what is the entire angle to get to that red line there going to be? How would I find that?
194.
Wait, yes, 194. Because we take 180 and we add that 14 to it. Okay? So I get 194 degrees and 14 degrees technically in this interval from 0 to 360. Both are going to give me 0.25 when I take the tangent of that angle. Okay? So you got to remember which quadrants are positive. These ones might be a little bit tricky on the homework, but I think there's only 4 of them at the very end. So try your best on those. Okay?